invited to speak. It's nice to feel like I actually know enough to share some knowledge. So happy to be here and do that. Um, so yeah, this little project started literally because I wanted to find a way to keep practicing my coding chops because it's use it or lose it, and they do disappear rapidly if you don't. But also just the practical skill of automation because we all have to do that in the real life. You hear about it, um, and so it's like merging those two ideas together with a fun idea, right? Because like the project's got to be fun. So what's more fun than like cracking hashes, right? Cracking passwords. So that's sort of the genesis of why I did this. Just a brief background about me. I've been studying cyber for a little over 2 years. Started during the lockdown. Just fell absolutely in love with ethical hacking, penetration testing, and saw the demand and wanted to make a difference. Join the good side, beat back the baddies, right? Uh, and I'm coming from a completely unrelated field. I pivoted from owning and running an auto shop that I did for just under 15 years, and so as far as like what have I done training wise, I've completed 5 Python courses, um, a course in C and a course in Rust, and then I've just been using Bash daily. I remember my first little scripting tool was through one of TCM courses where they just have you write a Bash script to scan ports, right? Just simple, couple lines. But that's the thing about Bash. It's to me, it's like a grocery list that you hand your computer, right? Because if you think about what Bash is, you're just duplicating what you do on the command line, but you're doing it at machine speed. So that's where, even though I had some skill with other languages, this seemed like the tool for the job. And so then the rest was, the devil's in the details to get it automated. Um, so with that, let me just introduce you a little bit about what comes in this package. So I have it all wrapped up in a zip file. There's about 11 files, and it's kind of like everything that I think someone would need, especially if they're brand new to AWS, to get started quickly. And so along with that comes with a how-to guide that I put together, which sort of looks like this. I try to make it walk you through from, hey, I don't even have an AWS account. What's an S3 bucket kind of stuff to ramp you up. And then with this latest version 2, I added some more features to make it more secure, number one, because we are security professionals, right? And also to make it a little bit more user friendly with some menus. So, and it's only about 300 lines. It originally was about 115 lines, but then I was like, hey, we've got hard coded credentials, and it didn't have a lot of bells and whistles. So it's amazing how it almost tripled, but that's the way it goes, right? I mean, look at Windows, right? Um, but yeah, so when you unzip it, you get like a starter kit of various hashes. Uh, so you can really just get this thing going right away. There's a 66 million password list. And what I did here is I took SecList, which I'm sure you're all familiar with, and they have this password directory of a compilation. And I just combined everything into one big list. So you can start with a simple dictionary attack. And then it has your config and your defaults, which just help you quickly set up the hashcat commands and get you started. So with that, I'd like to just demo it for you. What we'll do is we'll go ahead and attack this 1,000 MD5 hash file, right? And I just made a bunch of self-generated MD5 hashes because it's a relatively fast hash to crack. And without any further delay, let's go in. So we've got it set up to work on mode 500, which is MD5. We can change that if we want on the fly with menu 3, and it's already set up for 500, so we can just hit enter all the way through these if you're happy with it. We've got it pointed at the correct hash file, so we're good there. We'll keep that. Dictionary file, we've currently just got the one, but of course I invite you to have your own custom lists as you learn and progress. Instant type, just briefly go over this. AWS has its own little nomenclature, if you will. I happen to find recently the fastest single GPU that most people can access. They're very restrictive on going above one GPU, at least in my experience, and I've been trying to get more than one for over a month now. You have to actually request permission to access a GPU right now, which usually you can get permission and they'll approve it within 24 hours. But having said that, this is the fastest that everyone can generally have access to. Prior to this, while you're waiting for your permission, you can use any of the free tier stuff. So like a T3A micro, for instance, and at least you can make sure that your config is correct, because it'll go through all the steps and you'll know at least, well, maybe I can't crack a hash right now. Everything else is working properly. So we'll leave that alone since it's at the fastest instance. This AMI ID is strictly just points to an Ubuntu 22.04, which I just found that particular OS worked and played with all the other moving parts very well. So we're using a super modern Ubuntu instance. And we can call this anything we want, right? This is just a personal alias for the instance. And the default region is US East 1. You may be in a different region, and so this is where you would enter that. And the PEM file is whatever. A PEM file is like an ID RSA file. It's just your key pair, so you can connect remotely to your instance. So you'll download that services account, and then just place that in the current directory. And so this is where you would enter that. And it's always going to be Ubuntu as the user for SSH when we're using these Ubuntu instances. The only exception that I've encountered in the AWS environment is when you would change this is if you're using like a micro or a free tier, because those are EC2. That's the user EC2 by default. So this is a setting that I've already pre-configured, and you can just leave it alone. And so we're good. It confirms with output, so you can double check all of your variables. And now we just have to literally hit 2 for run, and fingers crossed, everything works properly. So it'll sit here. Of course, we're spinning up an instance, and I've got this AWS
console window, yeah.
So that we can actually verify, right, what's going on here. So we just have to refresh, and we see that now we have our crack rig, right, that we just named it, and it's running, right, with a G5 extra large. So it looks like it's doing what we expect, right?
Definitely.
And then I just left the output here because, first of all, I needed this output for debugging, but I also just think it's kind of fun. It's a little bit Mr. Robot, right? You're watching this instant build itself, which I still kind of enjoy. So, and it's just carrying out exactly what we would be doing on the command line, right? Just manually. And it's like, hey, once you figure it out, once you've got the command syntax down, why keep repeating it, right? Like that's the beauty of automation, right? So what this has done is after it's loaded the instance, we immediately went into like an apt update upgrade, which is pretty standard, right? So we have access to all the current NVIDIA drivers and anything else that this Hashcat needs to rely on. While this does its thing, I want to talk about like 3 major challenges. Of course, there were a ton of things to work out here, a lot of moving parts, but the 3 that really stood out to me is really going down the rabbit hole and taking a lot of time the game changer, the one that almost made this so I almost said I almost scratched it, was at the end. I had gone down through hundreds of tests. Everything was working beautifully until it didn't. And something happened. I want to blame this on NVIDIA, but they're when you access their servers through the normal apt repository and the depackaged repositories, there was a bottleneck in their back end accessing the CUDA servers. And keep in mind, the CUDA servers are the CUDA drivers are about 3 gigs, so it's not a small file. And all of a sudden, what usually was taking sub 10 minutes to complete was taking 75 minutes. So you could imagine, like, no one's that long, right? Including myself. So I literally had to find a shortcut, a bypass. And part of me was thinking, well, I'm just going to offload this to everyone. It's going to be part of the zip file. But I'm like, I don't want to give everyone a 3 gig file. That's huge. So that was my last resort. I didn't want to do that. But I did some Google Foo, and luckily I found a shortcut, a way off the main highway to access the drivers I needed without the bottleneck. So that really stood out to me as like that was a big hill to climb. Another one was figuring out the proper order of events here as far as it loading. I ran into a package daemon that would come up on the screen. Oh, it's standard with Ubuntu, and you'd have to sit there and it would ask the user for, we need to restart services. So you had to sit there and manually be at the keyboard. And obviously that was a no-go. And I had to figure out how to work around that. And luckily it was just a matter of changing the order that I was loading things, and then that disappeared. And now you can see how quickly this is loading. That's 3 gigabytes, and it just loaded it in under 10 seconds. So very pleased with my little bypass here. But yeah, so those are some of the big challenges on this. And I only share that because if you ever, in your own coding projects, we're all going to stumble. We're all going to run into these like seemingly impossible problems that sometimes keep you up at night. You go to bed with them, and then hopefully you wake up with inspiration. But they can be very challenging, right? They can make you almost quit. And what works for me personally is you got to step away, breaks. I like to walk, get some fresh air, try to get that bird's eye view again, because that's the other problem when you get into these code, you get too close to the problem is what happens, right? You are there in that command sequence, hitting your head, frustrated. It helps to step away. It also helps to, like, this is where I love talking to AI, like a rubber ducky, if you're familiar with that term. But you're actually the act of verbalizing the problem in a correctly, right? Like, hey, instead of like using loose language, you have to be pretty specific, right? When you're asking for help to a solution. And so I think that it forces you to verbalize it, and just the act of verbalizing in a lot of cases, the solution comes to you. So just a couple things I've learned along the way to keep your head in the game. So yeah, it's just now it's unpacking. Now keep in mind, this 3 gigabyte CUDA driver, it's a monster. There's 86,000 files, so it's got to do its unpacking here. There's actually, as fast as this particular instance is, I've talked to some inside AWS guys, and you can set up instances. They're way more expensive, but you can use RAM drives. I mean, they've got monster RAM drives, so everything happens in nanoseconds. If you wanted to go down that rabbit hole, but be prepared, because they're a couple $100 an hour to rent. So even like a 10-minute hash crack would cost you, it adds up, right? But it might be something fun to try once, just for that need for speed. But I'm thinking, what else? This is about 3/4 of the way done here, and I think I've covered pretty much everything here. Um, like I said, I spent some time putting a really nice how-to guide here with a table of contents, so you can just use it more like a reference manual to get you up to speed. And it actually has a link to a YouTube video, so you can see pretty much what is happening on screen right now, and to help you through whatever setup issues that you may not encounter. I tried to like think of everything, right? Like test it on multiple systems and sort of stepping in the shoes of the end user. So added some logic at the end to make sure your files were in the present working directory, and just other error handling to make it as smooth as I possibly could. So and there we are. We are at the tail end. So this needs to do a quick reboot for all these settings to take hold so that Hashcat can finally do its work. So we're probably at, I don't know, 7-8 minutes, I would imagine right now. And it's, as you can see, I haven't touched anything other than that original command to run the script. And this will come back online here. There was always the timing, the buffering, because every instance is slightly different as far as when it comes back online. So I had to sort of built in a little bit of fudge factor to account for that. But now you see it just uploaded the 66 million word password dictionary, and it did it. I mean, it did it in like what, 3 seconds, and now it's cracking with the big A10, and we can start to look. We'll give it a few seconds, and we'll look at status. So you can start to look at the specs here, and we'll see how quickly this thing is starting to work on this. So you can see we've already recovered 85 passwords. There's 1,001 loaded in that file. It's already, in 3 seconds, it's done 85. So that's pretty fast, right? And where am I seeing it? Because it normally does a hash per second count. So we're at, what is that? 25, it's kilohashes. So we're at 25 million hashes per second with 1 GPU. So, you know, that's pretty quick. It's a lot faster than my laptop anyway. So we'll do another status. And now we're about halfway through. So think about this. Like, we've all been on TryHackMe. We've all done our own little Hashcat John on our computers, and we know how long it takes, right? This thing is done 500 cracks in, where we at, 48 seconds. So we're in a Ferrari, folks.
Yeah, and I saw in the first status you said the estimate time was about like 40 minutes, but right now, or when you did the status, it's 23 minutes. So it's
Yeah,
crazy.
so it is pretty crazy. Obviously, the time they're overestimating it. I have no idea where they come up with, but um, believe me, it's going to come way under this. In fact, here we are. We're officially done with that, and it's terminating. And there it is. There's the output to screen, just for, demo effect. But you can see every hash has got a cracked password next to it. And if I stop this just to get a time, it was a little slower for some reason. It was probably stage frightened, just like me today. So it took a little bit longer, 14 minutes. And maybe because I did some walkthrough when I started the menu. But I've been averaging about 10 minutes to crack 1,000 MD5 hashes with this current configuration. So, but the beauty of it is, like, once you get your settings all set up, we could just go to lunch. We could go grab a coffee. We could just step away from the keyboard, which was my overall goal, right? To fully automate this entire thing. So, of course, my next idea would be to have it email you, because let's say you have a much computationally slower hash algorithm you're working on, like like a SHA-512 crypt, which is a lot slower. And so this might be running for 30 minutes or even an hour or multiple hours. And keep in mind, this concurrent configuration costs 52 cents an hour. So it's still pretty affordable to run for more than a few hours. But the nice thing would be to have an email notification or a text even, right? Like an SMS, like we have cracked your password or something like that. So that was just an idea I thought, and may invite you guys, uh, you know, make this your own tool, right? Add some bells and features. So yeah, I think I've reached all I wanted to say, and I wanted to open this back Q&A and feedback. However, what would you like to know or talk about?
Yeah, the first question I came up like this instant type, the 5G, it's large. Is that the largest we can get, like as a consumer of AWS, not as a company? But
Hmm.
how many of these can you launch in parallel?
You mean like at the same time, how
Yeah,
many can you? So let's go into limits here. That's an excellent question. They're really liberal on how many you can run at the same time. Just because I'm nobody special. I don't have any special privileges. I mean, I'm your $10 a month. I've been free for a year, so I certainly haven't been spending a ton of money with them, and I don't have any inside tracker here. But if you can see, this is sort of the current limits. They call them quotas. And this is what I started with. Now I asked for this because I at first I thought I was going to be in this direction, but unfortunately it wasn't helpful. I was asking for a bunch of CPUs, or they call them vCPUs, because I thought the more I got here, the faster I would go. But no, you need to you really need to get GPUs if you want to play in this arena. But
yeah,
as far as like we have AMA sharing, which is at 1,000, which is crazy. Look at this AMIs. I have access to all 50,000 of their, which is kind of their library. So I can be Mac OS, I can be Ubuntu, I can be Linux, I can be Kali. There's over 50,000 instances in their library. I'm looking for this setting, Leon, to answer your question here, as far as like simultaneous instances, and I'm not currently seeing that setting. Um, but I know you can. I know that you can do multiple. Uh, I haven't explored that to have firsthand knowledge of it. But I think they give you more than you need right out the gate. Um,
yeah. That's one improvement I will say for multi. Like, let's say you have 2 million hashes to crack. You
yes.
you can do something crazy and launch, I don't know, 20 of these instances and have the
Yeah.
script split the hashes into the 20 instances, and each one of those crack the hashes. And
You're
it will be
absolutely right.
much faster.
Yes, like divide the workload, right? You absolutely could do that. There's so much that has yet to be explored on using Hashcat. Um, and as you can see, we don't even have any running because they've all been terminated. But yeah, I mean, this is a deep rabbit hole. Password cracking, using rule sets and custom word lists, and even just building. They call it masking, prints, and what's the other Markov. So there's the rabbit hole is deep on this as far as dictionary. Um, Dictionary attacks are probably the most simple, but the problem is it's only what we know, right? And we all know that passwords are getting fancier, they're getting longer, they're getting more random, and they're not always conveniently in a dictionary. So you're out of luck if that's all you know. If you're just a one trick pony and you're looking to get that extra 20 to 30% hit rate when you're on an engagement. Well, then you have to get fancier with mangling and some of these other rule-based systems that are literally building passwords on the fly. Like you might have a smaller base dictionary, which will actually make it faster, right, than having to go through and exhaust 66 million hits on each password. You can imagine the computation there. It's quite inefficient, actually. But the other way is when you're building, they call it key space, right? So you're going through every ASCII character in the dictionary, and maybe you add some symbols and some other things, and maybe you define some rules. It's got to be at least like your average banking password is at least 8 characters, right? They want at least one capital, they want at least one number, and you get a variety pack of symbols, which are usually 5 symbols. So you could actually design a mask and a rule set to just go after that with a much smaller dictionary. And so yeah, there's a lot to explore here, for sure.
I believe a lot of people that are here are wondering what are these rule sets you're talking about? What are they, and how we can use them?
Excellent question. And I will not even pretend to be an expert here. I have played with maybe 3 of the hundreds of rules that are available in both John and Hashcat. Um, in John's, for instance, there's an entire config file of rules. I've read some documentation, which I'm happy to provide some links for people to explore that more, but it goes into a whole password theory. In fact, I just picked this up on Amazon. Um, Hopefully you can see this, but there's actually a book, which granted, you can find all of this scattered on the internet. Um, I recognized almost everything I came across in this book, but this is actually by the author. I believe he even signed it, which was pretty cool. That the actual Hashcat guy um, signed. I've got an autographed copy of his book, but
What is
I
it
just
called?
wanted something. Say that again.
What is it called? The book?
This is called Hashcat Password Cracking Manual, and I think I picked it up for like $7 on Amazon.
Yeah,
So
cheaper
it's a little bit,
than school books.
yeah. And I just wanted everything in one place, and and part of me thought there might be something unique that's not online. But the main benefit, I skimmed it last night. The main benefit is all the information is in one place, which I just find really handy, right? And he's got a lot of um, common commands that are handy to know because sometimes you get hung up on the syntax and you can't remember exactly how to type a certain thing. So he's got all that there. Um, but back to your question on rule sets. So there is the rule to rule all rules. I don't know if you've come across that, but that's something that you can download right from GitHub. And I think there's like 55,000 individual rules, which is just insane, right? You would think it would just bring your instance to its knees because that's just too much. But the idea behind a rule set is to have a very small dictionary. Like just to use a silly example, but let's just say that you had an organization that everyone used some kind of permutation around the word password. My God, right? But as an example here, so you wouldn't have to have a very big word list to start, right? How many ways can you type password, right? And then you would have it go against 50,000 odd rules, and just every permutation you could think of with every symbol. You could start it with an asterisk, end it with an asterisk. I mean, and you might just have a few things that about that particular um, company or organization that you're working with. That they have a minimum. You might have access to their rule set, right? So it's got to be between 8 and 15 characters long, uh, and they're requiring, just like we talked about earlier, you could actually you could actually set minimum and maximums inside of Hashcat right at the command line. Use these rule sets and pretty much get every hit of that narrow. It's a relatively narrow band when you think about it. A relatively small set of conditions and a base dictionary to base all these permutations on. It's actually much more efficient, and you get a much higher hit rate than what we just did. What we did is, it's not technically considered brute forcing, because brute forcing is literally starting from scratch, like building a password, like A, all the way down, and then B, and then every permutation in between. That is actually true brute forcing. This is, strictly a dictionary attack. If it's in there, it'll hash every word in that dictionary and then just compare the two to your input file, and then if you get a hit, it puts it aside, right? So I hope I hope that answers your question.
Yeah. What happens if uh, the password is not in the word is it doesn't get generated with the rules? It just says it couldn't crack it, or it starts brute forcing.
Yeah, brute forcing. So you absolutely can miss passwords, right? Like that happens every day. Like, there's people that talk about 60%, 80%, 90%. I would love to
Sorry,
on a
it cut off right there on the
yeah.
90%.
So just, and again, my knowledge is very limited. I just don't have the experience to really talk about much more than an initial understanding of the theory of it. But here's sort of a methodology. If we had an active engagement, right, and we're testing policy compliance, okay, so we dump the hashes, NTLM, LM, NT, whatever. You run that through a dictionary attack first. You're going to probably collect statistically about 60% of them, just because humans are humans, right? We're still stuck in that mode of I need I need something that's easy to remember. I mean, that's just the reality. Guilty as charged. We're all sort of still in that, even in 2023. So you're going to get 60% roughly just from a good dictionary attack on something like a RockU or what I just put together with Seclist. Um, Now, how do you get that other 40%? That's where you have to start getting into what they call mangling and permutations, knowing something about the organization and their policy. Like you've probably heard of, a lot of passwords they got to be changed every quarter. So a lot of passwords were based on the season, right? They literally have fall, summer, spring, etc. And they usually have the year, right? So you would literally have, one of the most famous passwords in the wild was like summer 2021. Like that was someone's real password in an Active Directory environment. So that's where you sort of have to get creative. Um, there's a lot of, you can get into statistics as far as like looking at how our language is constructed, if we're talking about like US language, for instance, because that's the other thing. Are you testing passwords in the USA, or maybe you're in Amsterdam and they have a slightly different character set, right? So you'd have to account for that as well, because they're using a whole different keyboard, right? So you can see where this can really become, um, almost like a full-time job. Like if you want to get really, really good, um, there's really a lot to think about. But yeah, like what I've read, and again, I will remember to share that link because it's a very interesting article. It actually helped me solve a box that was all based on brute force when I was literally out. I was at my wit's end. I the only way to get into this box was brute force, and I, RockU wasn't cutting it. And this article really gave me some ideas, introduced me to these concepts that we're talking about and rule-based attacks. And that's what got me that. It got me in, and it taught me about, how do you get that extra 20%? Because they're just slight variations. That's the thing is, yeah, they're not in the dictionary, but if you just vary it just slightly, and that's what these rules are really good at doing.
Yeah.
But
Well,
by true experts, I mean, these guys are like just geniuses, right? I mean, mathematicians.
yeah. One last question from me. Have you
Sure.
tried for fun, just all for fun? Have you tried generating a 128 character password, making the hash MD5 SHA-256, and trying to crack it to see how much time it takes?
Okay, so you just unpacked a lot there. So you would like to test something. You'd like to create a file, and I guess I missed a file of what type of hashes?
No, just one password, but with
Okay, one password.
128 characters long, which is what
Oh,
most password managers can generate.
right. So like on the fly, like I don't I don't know if we'd ever crack it in at least for demo purposes. Like we could be waiting days and weeks. I don't think we have a robust enough setup here to do that in a timely fashion. You know what I mean? Um, that would just be yeah, that's too big of a job for our little humble Ferrari here. We would need like a serious setup to do something like that.
Yeah, it's just an unreal scenario
Hmm.
where you just have fun because I'm not using a 128 character password to log in into my Windows laptop on the AT. That's
Sure.
insane. And
It it
even more if
it
it's randomly generated.
yes. And I wish I could show it to you. I have not been able to find a particular um, guide online yet, and that's the beauty of a book like this. But it pretty much every known algorithm from like Bitcoin, Ethereum, password one, all of these, KeyPass, all of these different algorithms. He put them in order of how fast they are to crack, and because he benched his. Obviously, this guy's spent a lot of time testing, and so he's got speed ratings, and so he puts them in order. Not that you have to get into the weeds of knowing that MD5s are 25 million hashes per second, and like bcrypt is only 13,000 hashes per second. Just a couple things I remember from last night, but that's really not important. To me, what's important is when you look at like a sequential order, is you can get a relative idea of how secure. Like, let's say Kali, I think is what using. I think they use a form of bcrypt, right? 512.
Yeah.
Um, and and so you're looking at that, like how does that compare to like what OS 10 is using right now, which is actually quite secure. It's a very computationally slow. It's in the top 10 in the world right now as far as uh, everything's crackable given enough resources. Let's get that off the table, right? But when you make it to where it's in the thousands of years or even hundreds um, to do a brute force attack against you, you feel pretty safe, right? Like who's going to waste their time? Like, you have to step into the shoes of the average baddie, and they're looking for the low hanging fruit, right? They're looking for the easy win. So they might get access to an Active Directory because they know that those hashes are very fast. I mean, even just a laptop can crunch through those things pretty quickly, which is pretty surprising to me, knowing that 90% of US corporations or global corporations using Active Directory rely on a algorithm that is that easy to quick to crack, I should say. You know, that's that's alarming to me. Like why don't we have like a hash like you just suggested that's 128 characters long, like a one password, which not to say that that is the be all end all, but some of these other much slower, like why isn't Microsoft using bcrypt? And I know this is just a question for another day, but these are the things that I I start to think about when I look at charts like that, and just look at like why are we doing things this way, right? We could certainly, to me, much how hard is it to change out the algorithm a given piece of software uses on the back end? You know, like we've all probably looked at SQLite databases, and for the longest time, they all used MD5 hash, which has been deprecated for how long, right? A long time, because it's easily breakable with today's average compute. And you saw how quickly we just did it on this instant, right? So how hard is it really to change an SQLite database? I mean, literally, it's a couple commands, right? In the back end, like that's just a patch. So you switch out algorithms to something a lot harder to crack, and you haven't really reinvented the wheel, or we're not talking hundreds of lines of code and weeks of development. We're talking a relatively simple thing to do. So anyway, that's sort of my take on it.